there, so let's keep going. Hello everyone, my name's Stephen, this is Artem, stood here beside me. We're going to give a very quick run through the OpenAPI work that we've been working on with a few other people across OpenStack. This is really two talks thrown into one. I'm going to start and I'm going to focus on the actual integration of OpenStack, OpenAPI schemas into various OpenStack services and the kind of things that we've been trying to do and how we're doing it. Artem then is going to give the more interesting part of the talk where he'll actually talk about what he's doing with these OpenAPI schemas at the moment, which is pretty cool.
Make them useful.
Exactly. But to begin with, Stephen Finucane's my name. I've been an OpenStack contributor for over a decade at this point, more focused on the Kubernetes side of things nowadays, running it on top of OpenStack, but I have a lot of experience at this point with various OpenStack services and their APIs. I've been working on OpenStack clients and OpenStack SDK in particular, plus Go for Cloud of late with my Kubernetes work. So I can tell you many war stories and horror stories of the good, bad and ugly of OpenStack APIs.
Horror stories.
Exactly, on another day.
Yeah. And I'm Artem, I'm working at System11. I'm currently an architect with more focus on identity access management. We together with Steven are mostly coming from OpenStack SDK CLI area, but currently just like spreading our hands into different areas. But there is no possibility to draw a line between them.
So we'll begin with a little bit of background. Just as an FYI, I gave us not quite the same talk, but a similar talk at the previous OpenAPI Summit in Suwon last year. I will give a link to this at the end, but I went into a lot more detail about the nitty-gritty of the implementation details and our long-term plans on OpenAPI. I'm not going to go into as much detail today on account of time, but those slides are available on the internet if anyone was interested, and there's an accompanying blog for them. But the things that I will talk about today, the why and roughly the how of what we've done with OpenAPI across different services. So as I noted, I maintain and have contributed to an awful lot of OpenStack SDKs and OpenStack clients. This is an example of some of the reasonably well-maintained OpenStack SDKs that are available, pretty much in order of completeness.
No.
OpenStack SDK.
No, the last one is brand new stuff,
yeah.
And from the level of completeness, it's 100% matching the APIs.
Well, there we go.
So that
probably should be bumped
covered
up.
in the OpenAPI is basically implemented in Rust at least.
Exactly. Beautiful. But yeah, with the exception of the Rust thing, which benefits from all the OpenAPI work, writing and maintaining SDKs is very hard, very tedious work. The OpenStack API surface is huge. Not all of it is very well understood even by the current maintainers of various projects, because there has been, it's an old project, it's 15 years old. There's been a lot of churn in the maintenance of the maintainers of various clouds, and a lot of stuff that has kind of stuck in and just manages to survive like cockroaches during a nuclear war. And because of things like API extensions and API microversions, we never really kill bad APIs. So we have APIs that exist in Nova that should have been got rid of a very long time ago, but they're still there hidden behind old microversions. If you're writing client tooling, you will have somebody that will come and ask to use this particular API that should have been got rid of 10 years ago because they have a use case. And there's also a whole load of other issues. Artem will talk more about this, he'll talk at length about this if you ask him. OpenStack clients and OpenStack SDK are really slow. Part of that comes down to the language they're written in. A lot of it is OpenStack APIs themselves can be slow, and you don't do a great job of caching things. Also, when it comes to some of the less used APIs, the level of completeness can be hit and miss. OpenStack SDK is relatively complete. As Artem said, the Rust bindings are generated from OpenAPI, so they should be 100% complete. But I know for a fact that Go for Cloud, there's a whole load of stuff that's missing in Go for Cloud. It's mostly the lesser used stuff because nobody has gone and implemented it, but it is missing. And if you try to reach for it to fix a particular issue you have, it's not going to be there. You need to go and implement it yourself. And then there's other things like we've got new languages that are popping up the whole time. People want to be able to talk to their OpenStack cloud from whatever, Ruby, for example. Not that that's a new language, but some different language, or in a different environment that we're not currently supporting. And then we'll touch on this in a bit, but an awful lot of services have derived from other services. So the amount of services that have derived from Nova and inherited all of Nova's original technical decisions around the web frameworks and libraries they use is quite high. Quite a few of those are getting to the point where they're no longer fully maintained, if they're not even end of life. We have a problem there in terms of keeping those things active. So the solution that we've come up with for this is to go full steam forward with OpenAPI, specifically the 3.1 release of OpenAPI, and in the future the 4.0 release, which Artem will talk about. There's a couple of things that OpenAPI 3.1 gave us, because, as I'll touch on in a second, we have explored using OpenAPI and OpenStack before, back when it was called Swagger and OpenAPI 2. But the big things that we get the advantage of here is the superset JSON schema. That is important. I'll touch on that. And the support for extensions, which again I'm going to touch on. This is an example of what OpenAPI looks like. I'm not going to go into too much detail. There's plenty of stuff on the internet about this. But it allows you to define things mostly in a RESTful manner. We are abusing it slightly to allow us to do the more RPC style interactions that you get for like the Actions APIs in Node and stuff, but it is generally REST style applications that you use it to document. And yeah, that's pretty much everything on that. So before we go into the actual implementation side of things, a couple of things that's worth noting. Firstly, from an OpenStack SDK or OpenStack perspective, if you have ever worked on any OpenStack API, you'll be aware of the API ref that every service has. Why do we need OpenAPI when we have API ref that in theory describes everything that we want in a machine readable manner? Here's an example from Keystone. As far as we're concerned, everyone needs OpenAPI. There's a couple of issues with the API ref. It was a very good solution to a problem where there wasn't many solutions available at the time, but issues that we have with it, the lack of machine readability, the inability to verify it against how your cloud actually works and confirm that your API spec matches the actual API itself, the use of restructured text, which has unfortunately fallen out of favor with regards to various markup languages, and the idea that it's effectively a separate entity from where your service is actually defined. And then, as I noted earlier, how we tried this before. If you click through those, that is a link to multiple specs and posts and that from back in the day where we tried to integrate Swagger. The big change this time is these two things, which we get out of OpenAPI 3.1. Why OpenAPI over these other things that have popped up in the last 10 years? Also that's.
And we tried a different way.
Yes.
We just stopped trying to get the community on that and just started really implementing that ourselves and got the traction.
Yeah. And again, coming from a Kubernetes background over the last couple of years, OpenAPI is very widespread at this point. The level of tooling support that's out there is really high. We do need to do some funky stuff for things like API microversions, which I'm not going to go into too much here because I covered it in the previous talk. But the tooling is there, the generation of clients is there, the documentation around the various various weird features of OpenAPI is very well documented. So how do we actually go about doing this? Very high level overview. There's two ways of integrating OpenAPI into an application. You can either do applications that are derived from your schema, so you write your schema first and then you generate a server that conforms to that. Or you can do the opposite way around, where you define your application and then you layer your schema on top and you validate to make sure that the application is receiving and returning what the schema says. Because OpenStack is now 15 years old, we have obviously gone with the latter approach. And then the fact that, especially with 3 and 3.1, you're allowed to layer on additional metadata into your schema. You no longer have to prefix it with like the X stuff that you used to have to use for HTTP headers. We very much rely on this already, and we will be relying on this a lot more in the future to build on things like microversions and so forth. And then from an OpenStack perspective, most of our application, our services are using a combination of Paste, WebApp, and Routes, which are all pretty old web frameworks. But they're not all using that, so we need to be considerate of that when we come to actually implementing things across different services. How we've gone about doing this for the various services, which we'll go recap in a moment. We have made extensive use of decorators. I'm guessing most people in here have written some amount of Python, but a decorator allows you to wrap a method or a function and layer on some additional functionality on top of that. We use it to wrap the various controller methods for our APIs to both inspect the request schemas, so in this case your query string schemas, and also anything that we give back, response body validation. The response body validation is opt-in. We don't enable it in production. We tell people don't enable it in production because you don't want it. But we haven't enabled any of the projects that have started integrating schemas into the project natively. They all have this enabled in their CIs to make sure that they are validating everything that they get back from the servers against their schemas, and in effect validating their schemas that way. The actual definitions for the schema, they're just stored as dictionaries within massive schema files. These are all being handwritten at the moment because, again, we have to write schemas to match how the application behaves as opposed to the other way around. In the future, we might be able to flip that around and allow us to replace, for example, the WebApp Paste model with something like Flask if we needed to. But at the moment, these are all being handwritten, which is at times extremely tedious, very satisfying when it gets merged, but extremely tedious to actually write things. Here is another example. The previous one was from Nova. This is us doing the exact same thing in Manila, where again we're layering on request query schemas and response body schemas, and we also do request path parameters in Ironic and various other projects. And this is what it ends up looking like. This is what Artem's going to touch on now, an example of the API documentation that's being generated from the OpenAPI schema that Artem is able to build.
So basically, it's a sort of a hybrid of how Swagger is visualizing the API specification together with the old style of OpenStack, just not to introduce too much difference compared to the old style. It's basically really completely generated out of the OpenAPI spec. So generally during the generation of OpenAPI spec, I'm using APIREF to extract some certain data, and then outcome of that would be a new APIREF, which is itself built then from OpenAPI.
So I'm going to hand the floor.
Yeah, that's right. Okay. So you see all those check marks. Check marks mean that from the JSON schema point of view, at least from the schema's point of view, we are nearly complete. There are some asterisks you may notice. That is, the PTLs of the corresponding projects know what they mean, at least to a certain extent. We are still working with multiple projects regarding the completions. Yeah, there are some start projects in the sense that those projects are really very open to collaborate on the effort.
And they all have native schemas built into them.
Yeah, they all have native schemas, yeah, maybe not complete, but the project themselves are also very open to actually improve the work. Regarding Swift, you see that here asterisk is basically the OpenAPI spec for Swift is completely manually written, but Swift API doesn't change since like 5 years, 10 years or so it's not a big problem. Just adding a new project costs quite a lot of time. It's roughly like a week of work just to start onboarding the new project, figure out all the, how Steven mentioned, that every routing mechanism needs to be handled differently, every project is having their own quirks, so it's relatively complicated. But you see the generally amount of coverage from the services point of view is, I would say, relatively good. So at least from the Rust CLI SDK TUI point of view, I'm also covering already all of those services. So in my eyes, quite good progress, especially that mostly we are just working alone on that. So code generator. This is an area what exactly is being, well, it's actually serving two purposes. Well, I try to describe it. So on one side, code generator is being used to generate OpenAPI specs from the service code of source code of the services by introspecting the code and capturing all those decorators, extracting schema information out of them, and basically doing some sort of conversion into the OpenAPI style of way. And the second thing that code generator is capable to do is actually to generate something useful out of the OpenAPI. It's not enough to have simply OpenAPI. I'm using that to generate SDK for Rust, new Rust CLI, TUI also for OpenStack, basically exactly with sort of zero effort. Well, of course, there is an effort to actually implement all of that, but once everything is done, the maintenance is much easier. Yeah. Pretty much generate OpenAPI schemas out of the source code and generate bindings for different programming languages or whatever you want. Maybe even org can be generated using code generator without any problems. Schema, I don't know why you posted that, I don't remember. Yeah, okay, just again back to schemas. Generate CLI and TUI. This is just a screenshot of the TUI that is, as I said, generated from OpenAPI specs. I'm going to have a talk at 5:05 here in this room, is covering more details explicitly on that, going in details what it does, how it works, and so on. Yeah, here you see just listing servers in the TUI style. The TUI itself is really very K9s inspired, and I try to follow the same approach because quite a lot of people nowadays are already into Kubernetes area, so it feels more native to them. CLI pretty much exactly the same way, so you see the top the commands, output as a table pretty much the same as it is with OpenStack client right now with the Python one, just there with difference that at the moment I'm the only one who is doing that, and I have covered all of the services just with code generator, so the maintenance basically is close to zero. I wouldn't say zero, but it's like going into the direction, giving us possibility to actually focus on more useful things like adding new features in the sense of let's do some extraordinary authentication, let's implement some additional caching, but do not bother really on the details of how the API is looking like. How does it do it? Long live the metadata. Basically, you can imagine that we have now a bunch, like roughly it's I think around 15 megabytes of OpenAPI specs. What can you do with it? When you want to generate something useful, you need to add additional metadata because not every single API call makes sense to be mapped one-to-one on the CLI or on the TUI. There are definitely one-to-one mappings, but there are certain cases where you don't want to have actually any CLI binding, and you want to do some weird stuff. This is just an example from the metadata network security group. It just basically allows you to do mapping. So generally we are describing resource security group rule. The API version will be v2, and list of operations which we support for that particular resource. Create operation in this particular case. Operation ID is exactly the mapping to the OpenAPI spec. That is basically the way when we try to generate the CLI or SDK binding exactly for creation of the security group rule, we need to find that particular code in the OpenAPI spec, which is itself also not trivial. That is why it needs to be at least hard-coded for the moment. Operation type is something quite weird because also not every single post call is equal. Sometimes we are using post calls for creating resources, sometimes we are using post call to invoke connection, and so on and so on. So technically, from the API point of view, a single API call can be mapped to different sorts of actions that we actually want to perform on the resource. And then we are able to describe the targets. Target is exactly what we are generating out of that, with some additional supplementary information. For example, CLI full command would be more or less a suffix of the command, so OSC, blah, 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 and then we would have the name of the command, how it would be named there. And of course, last but not least, the path to the file itself. So technically the recipe, how it is all being done, I mean from the code generator point of view with regards to generation of the code bindings. So we take the OpenAPI spec and cut it into the abstract definition. ADT is abstract data types. Yeah. The problem that I'm solving with that is that one thing that is, or in JSON schema, you can describe a single thing in multiple different ways. And first we need to negotiate them, like nullable field can be described in the way that you have additionally typed null. It can be described as one of and also additionally the null, and so on and so on. So there are really quite ugly details of JSON schemas, and that is, so first I'm trying to convert them into something useful. And then I'm converting that ADT to target specific types, because again, nullable type in different programming languages would also need to be covered differently. In Python you do it one way, in Rust you do it in a different way, in Go you do it in a third way. So for every target there are sort of specific types. Then you apply dozens of Jinja2 templates for those converted types. You wait it for being cooked a little bit, and afterwards you have 7,000 plus files for the SDK CLI, but generally for you as for maintainer, it's you just press the button and that's done. And the perfect pipeline, this is something that I would be also touching a bit, at least in a little bit on my talk on Keystone NG tomorrow, which is where I'm experimenting with different approach for the open APIs. I'm building really that, I'm re-implementing Keystone in the way that I'm generating open API directly from the source code, which is the second approach that Steven mentioned, which unfortunately we can't do right now in the current OpenStack service, but which is really valid. And so once I merge the change into the Keystone NG, automatically pull request is being created into CLI TUI, SDK, whatever, with exactly the same change. So at the end of the day, from time to time, when I'm implementing changes in the code generator right now, I'm capturing changes like someone has updated doc strings for their services, like in Nova, someone fixed the typo in doc strings, and this way those changes are landing. But with the Keystone NG approach, when this is done differently, basically every service change which affects API immediately triggers the change on the SDK CLI. It means we as maintainers for SDK have time, precious time to do more useful things. And the next steps would be to just do it. Just do it, everything, yeah. And the nice thing with the code generator, at least that's the final part, when we are taking care of generation of open APIs out of the source code, we have a chance to actually generate open API in a different way for 4.0 when it comes out, with services actually not having anything to do. So it will be absolutely transparently for them. We are going also to continue work on this string extension, that basically at the moment for the normal Keystone, we are building also the API ref with the new style, so it's actually hidden, a little bit hidden, because it's still sort of experimental work. But we are going to basically roll it out more. The problem is at the moment where to capture the doc strings for the services, where to keep descriptions, which is at the moment something that needs a little bit of work, coordination work across services. Yeah, we continue working with Ironic team, with Cinder team, with trying to get them onboarded with regard to schemas. Yeah, so if you want to know more, take a look on Garrett for the changes. Well, nothing that interesting maybe, but anyway, yeah, ask us why is that on IRC, go to mailing list. We are here also, like Steven wrote, we are not biting. So you can come to us every time, ask, and we will help you onboard it. Or if you are having interest in supporting us in this endeavor, which is incredibly time consuming from the point of view of getting everything onboarded. But once we are there, everything is great. Life is great. That's it. Questions? Oh, okay. You are Phil.
Hi, Artem.
Hey, it's Jay.
Yeah, I
remember in person. It's nice to see you. Very good.
Yeah, I know.
My quick question was just, I know that microversions are pretty specific to OpenStack, and in the example you showed of the generated Swagger documentation, I didn't see a lot of reference to it. Is that something that y'all have worked out, where like if people look at our docs, they're going to be able to cross-reference, how the API behaves differently in version X versus version Y?
As long as this is just different from the schema point of view, everything is great. When we are having differences, like with a different API version, everything changes, like you are doing completely different API call, then it's more problematic. But technically speaking, from the OpenAPI point of view, we are generating a schema which is having one off, and every kind of one off is having additional metadata describing which particular microversion it is tied to, which ends up in the fact that you are having really huge OpenAPI spec. For the human, it's hard to read it. I need to admit it's hard to read it, but OpenAPI specs are not created for humans. Those are created for machines, and we created machines that are really very good at reading those exactly. This type of
So we layer on metadata effectively that your client needs to be aware of it. So if you have your typical CLI generator tool and it isn't aware of the significance of that metadata, it won't understand it. It'll just target probably the most recent version or the first version of an API.
It all depends.
Yeah, target one of them, but once it's aware of it, it can start targeting specific versions.
Is that going to be adopted into like the upstream standard of that, or is it always going to be an extension?
This is what for the load. This is what we're hoping that we're able to affect.
No, FODATOR doesn't really touch that particular aspect. It helps a little bit more with RPC style invocations, but it doesn't help really with microversions. Well, it's actually technically, it adds a little bit of more improvements in the area of additional headers or differences according to the API headers in the request. Then it gives you a little bit more possibilities. We, however, do not know in detail because the spec is still not really in the proper draft version. It is being postponed and postponed and postponed and reworked, and then they have figured out, no, it's apparently way too much of restructuring it at once, so we will try to cut it down into slices with 3.2, 3.3, 3.4, and everything else, but there is still no real, no good roadmap for that.
Yeah, I suspect we'll always have to carry something specific to OpenStack because, as you say, microversions are very much an OpenStack thing. It doesn't really make all that much sense but we have extensibility built in there. We can do our own OpenStack prefix options and stuff.
Thank you, and I probably owe you all a lot of reviews on Ironic, so I will keep this in mind.
Yep.
Yeah, the question is more regarding towards, we are heavily using Gopher Cloud, which is now currently in the major version 2. Is there then, until I saw now the major projects are now being worked on, which is, by the way, a very cool thing, thank you. Is there then still a phase of maintenance of manually done stuff until it's fully generated, like from a struct perspective? Because we are missing some fields, so there will be...
At the moment, Gopher Cloud is not using code generation at all.
Yes.
And actually, we are all very open, and we need to find each other. Just close us for a week, basically close somewhere in some hotel, and we will implement that. Yeah. But at the moment, it's just not there.
Okay.
It requires quite an effort.
Okay, and it will be then, I assume, tied to like a new major release version, or is that something you don't know yet?
Probably, because it's going to be very difficult to map what we currently have on top. We're going to say this is how we translate a field from an API. We'll turn all these into camel case or whatever. It's going to be very hard to layer that on top. So there's a major version of Gopher Cloud, like a V3, coming at some point in the next year anyway.
So
that's what the main
up until that, like if you miss fields in structs or something like that, just regular pull request way?
Yeah.
Okay.
Yeah. Same for SDK.
Yeah, but with regards to those conventions, this is something that on the Rust side I have literally felt was feeling really the hard way. There are so many things that simply get broken. That is also one of the reasons why I decided not to continue approach of trying to start generation Python keystone client, because I have just figured out it's gonna break everybody, because in every single case there are certain minor changes and everyone will be just pissed off. Yeah.
Another question is about like the choices fields. So more like there are options which are basically string based, where you have multiple options, which in an OpenAPI spec I would standardly use an enum for. But an enum in itself is, if an enum changes, is a breaking change. Is there some idea of using something like X extensible enum, which Zalando uses, or?
I wouldn't say not in particular. We try to, at least I personally try to stick as much as possible to the native OpenAPI without extensions, because we have already quite a lot of extensions and it makes it harder. And that is also a reason why I'm first converting that to ADT, because I can figure it out. There is no single way how to convert JSON schema into the Python code or into the Rust code. These are completely different worlds.
Okay.
Technically, at the moment, I simply try to support all those deviations. So if it's described like one-off, then I still try to normalize it during conversion to ADT, so that then for the Go, for Rust, for whatever language, we try to generate it reasonably. Okay. So it's basically, we try to support OpenAPI being very flexible, covering variety of different ways, while then when applying code generation for the final bindings, trying to normalize this.
Okay. Now the question was whether if you use the enums, you could then also use like the OpenAPI validator to just do the pre-validation of the values, or even client-side validation. If you just keep it as a string, then it doesn't really work.
With regards to client validation, I am experimenting, at least on the Rust CLI side, SDK side, with basically it forces me to embed the schema directly also into the client side, which is not always the good thing, because every time the docstring changes, your changes are simply way too big. But yeah, I'm experimenting with that. Unfortunately, there are very many cases of services doing then server-side validation, which differs. Basically, one of the biggest problems that I have is that in reality, my big pain in the ass, is that every cloud in reality is different. So configuration for every cloud is different, and what is working in one cloud is not working on the second cloud, because they have to swap the flag in their configuration, and therefore validation just works differently. On the image, you can simply send arbitrary values, and those are stored. So that is where it becomes explicitly painful that you can't do client-based validation, because you don't know how the schema is looking on that particular cloud. And if you compile, if we are talking about Go or Rust or compilable languages, if you compile that, that would mean that this works perfectly fine for one cloud, but it will not work for a different cloud. You
I have a quick question. We use headers quite extensively in OpenStack. Service tokens, request IDs, and stuff like that. Are they supported in the OpenAPI schema?
Yes. The problem is, however, here with going back to JSON schemas, you can't specify, you can't describe headers in the JSON schema in the decorator. That is one of our biggest problems. And at the moment, I'm having a big set of quirks and workarounds directly on the code generator side, explicitly to cover those cases. But if you find certain things, I would be really very open to actually fixing them finally. But technically, this is exactly the way. You can't describe them on the service side. You need some different place where you are
Post-processing.
Yeah.
But are they already part of the generated documents?
Partially, yes. Partially, yes. Anyone else? No? Okay, then, thanks a lot.